In compiler design, the next topic is structure of a compiler. So we are going to see what are all the phases of a compiler, right? So we have the phases of a compiler. So when you are giving to the compiler source program, what is the output? We have a target program is generated by the compiler. So in between all these phases are executed, and each we are going to discuss what is lexical analyzer, what is syntax analyzer. So all the phases we are going to see. So these all the phases are communicate with the error handler. So whenever if the error is occurred in this phase, at a time this phase is return the error message to the errors handler. So all these phases are connected also to the symbol table, because all the symbols or all the special characters, all the keywords are managed by this symbol table manager. Okay. So the compilation process is a sequence of various processes. Each phase takes inputs from its previous stage, then it has its own representation of its source program and feeds into a output to the next phase of the compiler. So when it is taken as a stream of tokens, when you are giving the group of characters as a source program, right? So it is going to the lexical analyzer, then it is executing as a number of tokens. These tokens are input to the next phase of the compiler, that is second phase, phase of the syntax analyzer. So when it is taking as a tokens, the input of the syntax analyzer is number of group of tokens, and it is generated a parse tree. It is also called as a parser. So we are going to see what are all the different phases executed, different types of instructions. Okay. So first phase is, this is the first phase of the compiler. So it is also called as a scanner because it is reading the group of characters. It is also called as token generator. Okay, because the output of lexical analyzer is a tokens. So this phase scans the source code as a stream of characters and converts it into a meaningful lexemes. Lexemes means it is also called as a characters. Lexical analyzer represents these lexemes in the form of tokens. So that is token name, then attribute value. So here the tokens are generated as new value is identifier, and here it is generated for this operator also, assignment operator also it is generating one more token, and for old value also generating one more token. So here plus also generating the another token. So 12 also generating the another token. So how many? So consider this example, how many we have, how many tokens we have in this? 1, 2, 3, 4, 5. So total number of tokens are 5. Okay. So once executing this expression, it is generating the 5 tokens here. Okay. So that is our lexical analyzer. So what is syntax analyzer? It is also called as parser. So because it is generating parse tree here. So the next phase, it is also called, it is a second phase of our compiler. It takes the tokens as inputs produced by the lexical analysis. Then it generates a parse tree, that is nothing but the syntax tree. In this phase, token arrangements are checked against the source code of the grammar. That is, the parser checks if the expression made by the tokens is syntactically correct or not. So it returns to the syntax errors. So see here, consider the example. So as an expression is converted into the, this expression is converted into the parse tree. So equal to equal operator is as a taken as a new token. This is as a new token 1, 2, 3, 4, 5. So end of the parse tree we are getting 5 tokens here. 1, This is the second one. All the leaf nodes is taken as a tokens. 1, 2, 3, 4, 5. So this is our parse tree. We are going to see this brief session in the you have syntax analyzer in the unit 2. So we can discuss more about this, how to create the syntax tree, how to generate, how to take in the inputs, and how to take in, how to generate tokens as parse tree. Okay. So what is the main difference between the syntax analyzer and the lexical analyzer, right? So both of them do the similar things, but it deals with the lexical analyzer, it deals with the simple non-recursive construction of the language. But here the syntax analyzer deals with the only recursive constructs of the language. Here it is non-recursive. Lexical analyzer simplifies the job of the syntax analyzer. So it is generated already, it is generated the tokens. If it has any errors, it returns to the error messages. It returns to the error handler as an error message. Then it simplifies the job of syntax analyzer. Then if you have any syntax errors, then it will return the syntax errors. So the lexical analyzer recognizes the smallest meaningful units, that is as a tokens in a source program. The syntax analyzer works on the smallest meaningful units, that is tokens in a source program, to recognize the meaningful structures. So whatever the program is converted as tokens or as a parse tree, it should be a meaningful of our programming language. Okay, this is the main difference between the syntax analyzer and the lexical analyzer. So what is semantic analysis? Semantic analysis checks whether the parse tree constructed follows the rules of the language or not. So for example, assignment of values is between compatible data types and adding string to the integer. Then also the semantic analyzer keeps track of the identifiers, their types and expressions. So whether identifiers are declared before use or not, etc. Then the semantic analyzer produces the annotated syntax tree as an output. So what is intermediate code generation? After semantic analysis, the compiler generates an intermediate code of the source code for the target machine. It represents a program for some abstract machine. Then it is in between the high level language and the machine language. This intermediate code should be generated in such a way that it makes it easier to be translated into the target machine code. So in this phase, all the source program is converted into the target program. It acts as a bridge between analysis phase and as well as the synthesis phase. So what is code optimizer here? The next phase, which does code optimization of the intermediate code. Optimization can be assumed as something that removes unnecessary code lines. If the code is repeated, this can be removed by the code optimizer, and it arranges the sequence of statements in order to speed up the program execution without wasting resources, CPU or memory. So code generator, which is nothing but in this phase, the code generator takes the optimized representation of the intermediate code and maps it into the target machine language. Then the code generator translates the intermediate code into a sequence of relocatable machine code. Sequence of instructions of machine code performs the task as the intermediate code would do. So we have a symbol table. This is a data structure maintained throughout all the phases of a compiler. All the identifier names along with their types are stored here. Then the symbol table makes it easier for the compiler to quickly search for an identifier, record and retrieve it. So that symbol table is also used for scope management. Okay. So these all error, whatever the errors we are getting in the all the phases, these are all the phases returned to the error handler. So this is all about the phases of a compiler. So thank you for listening.